Hello everyone, today we'll discuss conservation of momentum. So before we start this topic, I would like to write impulse momentum theorem again. So what was the impulse momentum theorem? Force average times delta t equals mass velocity final minus mass velocity initial. I would like to rearrange the equation. So basically I would like to add positive mvi to both sides. Then I will end up here. Mass times velocity initial plus force average times delta t equals mass times the final. Okay, that will I will end up. So from there I can put here this is pi, which means momentum initial equals j, which is impulse, and this is pf, which is momentum final. So that is my general equation. So I would like to write it here again. So momentum initial, impulse, and momentum final. So if there is an impulse in a collision, then there is a change in momentum, then final momentum will be different. Okay, now let's discuss a scenario here. Okay, there are two objects, and those objects they will have a collision. Okay, so as you can see, they go toward each other, and here they collide and then they separate. Here I would like to talk about this part when the collision happens. So here we would like to recall Newton's third law. What does Newton's third law says? For every action there is an equal and opposite reaction. During collision, I would like to write it here. During collision, the force on object 1 by object 2 will equals force on object 2 by 1. I would like to put it here in terms of magnitude. Okay, in terms of magnitude, they are equal. They are equal. They are in opposite objects, as we can write here. They are in opposite. They are in different objects. So the forces are, there is an equal and opposite forces, action and reaction pairs, and the time for them is equals. So basically we can say that the impulse on 1 by 2 equals impulse on 2 by 1 will be equal. So there is an impulse, but in this system they cancel each other. Here we are saying that there is a force here, but this force here is called internal force. Okay, so when there is a internal force in the system, then the equation that we write above, which is momentum initial plus impulse equals momentum final. So if there is a force in the system, they are internal, which means the impulse cancel each other, then there is no net impulse. That's why initial momentum will be equals final momentum if the forces are internal. I can put a note here. If for the forces are internal. Okay, now let's discuss about collision types. Okay, there are elastic collision. Right now, let's discuss about that. In this system, there are two objects. And object 1 has a velocity 1 initial, object 2 velocity 2 initial. As you can see, they go toward each other, and there is a collision, and after that they separated. In this case, there is a elastic collision. In elastic collision, basically the objects are bounced. So in this case, if you write the equation, what is the momentum before the collision? I can let me use. Okay, so let's write the momentum initial, total momentum. So we have a mass of the object 1 and velocity 1 initial plus. We have a mass of object 2 times velocity of the object 2 initial. There is no impulse, that's why. Mass of the object 1 times velocity of the object 1 final plus mass of object 2 times velocity of the object 2 final. That is the equation we'll be using in order to solve the conservation of momentum. If the question asks you about there are some questions, you can use also kinetic energy. In elastic collision, kinetic energy also conserved. So we can write the equation like that: 1/2 m1 v1 initial squared plus 1/2 m2 v2 initial squared equals 1/2 m1 v1 final squared 1/2 m2 v2 final squared. So we can also use the conservation of energy. In elastic collision, energy is conserved. So what about another collision type? So in elastic collision, there are two objects, 1 and 2. 1, as you can see, they go toward each other, they have a collision, and after that they stick together. Okay, this is called inelastic collision. In elastic collision, still the momentum is conserved, but kinetic energy doesn't conserve. So let's write the momentum here. So mass of object 1 times velocity of the object 1 initial plus mass of object 2 times velocity of the object 2 initial. That will equals, that part is left side of the equation is momentum before the collision, and right side of the equation is combined mass m1 plus m2 and velocity is v final, and we can use this equation.